year, a Long March 2D rocket took off from the Jukun Satellite Launch Center in the Gobi Desert carrying a satellite called Metis, named after an ancient Chinese philosopher who died in 391 BC. The rocket placed Metis in a sun-synchronous orbit so that it passes over the same point on Earth at the same time each day. Metis is a highly sensitive photon receiver that can detect the quantum states of single photons fired from the ground. That's important because it should allow scientists to test the technological building blocks for various quantum feats such as entanglement, cryptography, and teleportation. Today, the Metis team announced the results of its first experiments. The team created the first satellite-to-ground quantum network, in the process smashing the record for the longest distance over which entanglement has been measured. And they've used this quantum network to teleport the first object from the ground to orbit. Teleportation has become a standard operation in quantum optics labs around the world. The technique relies on the strange phenomenon of entanglement. This occurs when two quantum objects, such as photons, form at the same instant and point in space and so share the same existence. In technical terms, they are described by the same wave function. The curious thing about entanglement is that this shared existence continues even when the photons are separated by vast distances. So a measurement on one immediately influences the state of the other, regardless of the distance between them. Back in the 1990s, scientists realized they could use this link to transmit quantum information from one point in the universe to another. The idea is to download all the information associated with one photon in one place and transmit it over an entangled link to another photon in another place. This second photon then takes on the identity of the first. To all intents and purposes, it becomes the first photon. That's the nature of teleportation, and it has been performed many times in labs on Earth. Teleportation is a building block for a wide range of technologies. Long-distance teleportation has been recognized as a fundamental element in protocols such as large-scale quantum networks and distributed quantum computation, says the Chinese team. Can an aging corporation's adventures in fundamental physics research open a new era of unimaginably powerful computers? In theory, there should be no maximum distance over which this can be done. But entanglement is a fragile thing because photons interact with matter in the atmosphere or inside optical fibers, causing the entanglement to be lost. As a result, the distance over which scientists have measured entanglement or performed teleportation is severely limited. Previous teleportation experiments between distant locations were limited to a distance on the order of 100 kilometers, due to photon loss in optical fibers or terrestrial free space channels, says the team. But Metis changes all that because it orbits at an altitude of 500 kilometers, and for most of this distance, any photons making the journey travel through a vacuum. To minimize the amount of atmosphere in the way, the Chinese team set up its ground station in Inari in Tibet at an altitude of over 4,000 meters. So the distance from the ground to the satellite varies from 1,400 kilometers when it is near the horizon to 500 kilometers when it is overhead. The search giant plans to reach a milestone in computing history before the year is out. To perform the experiment, the Chinese team created entangled pairs of photons on the ground at a rate of about 4,000 per second. They then beamed one of these photons to the satellite, which passed overhead every day at midnight. They kept the other photon on the ground. Finally, they measured the photons on the ground and in orbit to confirm that entanglement was taking place, and that they were able to teleport photons in this way. Over 32 days, they sent millions of photons and found positive results in 911 cases. We report the first quantum teleportation of independent single-photon kits from a ground observatory to a low Earth orbit satellite, through an uplink channel, with a distance up to 1,400 kilometers, says the Chinese team. Todd Holmdahl says that starting from behind won't keep Microsoft from winning the race to commercialize quantum computing. This is the first time that any object has been teleported from Earth to orbit, and it smashes the record for the longest distance for entanglement. That's impressive work that sets the stage for much more ambitious goals in the future. This work establishes the first ground-to-satellite uplink for faithful and ultra-long-distance quantum teleportation, an essential step toward global-scale quantum internet, says the team. It also shows China's obvious dominance and lead in a field that, until recently, was led by Europe and the U.S. Missions would surely have been impressed. But an important question now is how the West will respond.